For lessons 2 and 3, the solving absolute value. So yeah, we're getting into the graphing calculators. Remember, we have two methods. Stay with me. Two methods, intersection and X-Intercept. They get you the same thing, so one's not right over the other. Okay, well, let's solve the first one by intersect. So what that means is intersect, you're going to take the absolute value. I'll show you where to put that in your calculator in a second. Of 2x plus 3 into your y1. You're going to take the number of 8 into your y2. And it's going to give you a V with a line going through it, and you're going to find the intersection points. So let's go look at that real quick on the calculator. All right, so if I come up here, if you don't know where absolute value is, I believe it's in the math section. Math, number, abs. So hit the math button. Click over to number, and it's abs. Okay, and then it gets you the absolute value there. Yeah, because you need absolute value, yep. Okay, we'll do one more time. You go math, over to number, abs. Nope, 8's not absolute value, it's just 8. So we're just like this. Okay, there's my picture.
So there will be two intersection points?
Yep, so there's going to be two answers. Yep. So we are looking for these right here, guys. Here and here. Okay, so we go second trace intersect number 5. Just hit enter 3 times. It'll get you this one. 1, 2, 3. So that's my first answer is 2.5. To get the other one, I just got to arrow my cursor to the other side of the V. So second trace, intersect, arrow over. Then now hit enter 3 times. Negative 5.5. So 2.5 and negative 5.5 is our solutions using the intersect method. Just the X-Intercept. Okay, X-Intercept is quite simple. It's just kind of the same thing, guys. Just let's go back to y equals, and all we're going to do is instead of being equal to 8, we're going to minus the 8 over so that one side's equal to 0, right? Because that's what we do when we want 0, it's one side 0. So I'm just going to delete the 8 from here. Okay, I'm going to go up to the second one. I'm going to add a minus 8, and it's outside the absolute value, like that. So I just moved the 8 over. Okay, so if you're not following me, because I'm kind of doing it out loud, you have this. We just did this. We have 2x plus 3 equals 8. I just minus the 8 over. And so it just equals 0 now. That's how we find the zeros or X-intercepts, right? So then we put this into y1. That's what we're doing. What's that? You shouldn't have flipped. Let's go y equals. Oh, yeah. That's timesing it. Put a minus sign, not a negative. Okay, so if I go to graph here, there's my V. Okay. Now I'm finding the zeros. So that's where you do the... Yep, you're getting the exact same answers, yeah. Right. You're going to get the same answers, guys. Again, there are two methods to get the same thing.
So do you just substitute the 0, you get it?
No, you have to move the 8 over, though, right?
No, I'm talking about, like, once you get the 0, you just write those coordinates.
Right, these are the answers. We're getting the same answers. Negative 5.5 and 2.5 is still your answers. Okay? Does everybody remember how to do the zeros? You should know that from parabolas. Do you want me to do it one more time? Yes, please. The 0? Okay. 0, second trace, number 2. I already just found the left one, so I'm going to arrow over to the right one. So it says left bound. What that means is, here's this 0 on the right side. I want to be left of it. Okay, I have to be on the other side of the V, though. I can't do it right now. I have to come up the point here. Whoops, missing. There we go. There, now I'm on the left of it. Hit enter. I'm going to go all the way past the 0 to the right side of it. See, now I'm to the right of it. Enter, and then I get close to it. Enter. 2.5, which we knew was going to happen. Okay, so that's just two different methods for using your calculator to solve. Okay, so let's go ahead and pause for a second. Take off the video. We'll pause it. Oh, I don't want to exit. There we go. Okay, so I want you guys to try these two with your partner. Okay, if you don't have a graph calculator, I'll get you one. If not, share for somebody. Okay, but try these two on your own. So I would suggest, though, to get you started, I'd put this in y1, this in y2 for that one. Okay, this one you can pick. Do you want to use intersect or do you want to use 0? Okay, so go ahead and try those. All right, so I'm going to go ahead and skip in terms of calculator part showing this one. We got 2 5s, right? It was 2 5? So that means, let's see, I can graph this real quick, though. This is going by 2s, though. I hate when they do that when you're not ready. So it's -3. It's right there, and it's -3, so it's going to be up to 3, so it's right there. So this one looks something like this. And the 2x plus 1, right there. Yeah, so it goes, actually I go like that. So it goes like that. It looks something like that-ish. I'm a little bit off, but the point is you guys got 2 5, right? Okay, so 2 5s where it crosses. Okay, let's look at the second one, though. Let's look at that in the calculator. So I'll go through that with you. Okay, so we have, let's peek and see, it was x squared minus 17. Okay, so we got x squared. Was it, minus 17? Okay, minus 17. We arrow out here. I like the intersect method better personally. So I'm going to put in the 8 here. Okay, so graph. There's my W. I'll show you that it's kind of cool. It is. I want to show you something actually real quick. All right, let's cut off this side chatter. Okay, real quick. I want to show you something just for, it's going to help you with later. Okay, so there's the actual good picture of the W, okay? Now I want to show you what's happening. Or how about this? Why do we have a W? Good, but normally x squared is a parabola, though, not a W. So, right, the absolute value piece. So this is the part I want you to notice. This, normally, it would be down here, right? Normally, without absolute value, x squared minus 17 would go, whoa, oh, hey, that's cool. I didn't know I could do that. Learn something every day. Okay, so we'll use that right here. So normally, this goes like this. But what happens is this gets flipped up because it's an absolute value. It says, oh, that's negative. Puts it up there for you. That's what's causing the W.
So wait.
Yeah.
Does it matter if the parabola is negative or positive?
No, because if it's negative, yeah. Now that's a very interesting question. So if it was negative, he has asked a really good question. Because if it was negative, like let's say this was the original, right? And then these guys would flip up. So it actually could be either. It doesn't matter because the absolute value is going to flip it up no matter what.
Wait, so if it was like that, then would the whole, would it just flip the half?
Yeah, so now again, okay, you guys are doing great. Let's just go with this. So we know that the combination of the lines is the positive line and the negative line, right? The parabola is the same thing. It's a combination of the negative and the positive. So this right here, see this piece? This is supposed to go down. This line and this line is actually the x squared minus 17 line. Do we see that? Because that's what this is.
Yeah.
That's not what this is. This is the opposite.
Oh, is that if it flips it to x is plus 7?
This piece is the negative x squared plus 17. See, it's going to 17. It's a negative parabola. So it's the positive and the negative pieces combined.
Oh, so like the little arm is a positive and then it goes.
Right, in this case, yep. These guys are my positive pieces. This is my flip piece. So if I did piecewise, how many pieces do we have? 3. Positive, opposite, positive. For my pieces of my graph. Okay?
So,
We'll get to that, but that's just a cool thing to see that that's what's happening. That's why it's a W. All right, good?
wait, so if it would just be this parabola,
Right, so if the regular parabola, so sure, we can try to do this here. So if the regular parabola was a negative, well, in this case, if the regular parabola was negative, then this would be your original. But this is still technically the negative piece, right? Because that's the part. If that was part of the original, then it would be flipped up still. So
it would just make it
right. what I guess what I'm trying to say is this is our original, right? Well, if this is our original, that would not change that picture.
It would keep it the exact
Right, because it's still going to reflect the other stuff. And so it's
It'll make the same.
right, it's make the same thing. Okay? All right, you guys are doing great. All right, so, well, that was really neat. I need to do that more often. Okay. I can actually just take that and take it to the notes. Okay, so here's your steps, guys. Just read through the steps. I won't read them to you, but this is your steps for solving. Oh, wait, is this for the solving piece? Oh, no, we need to want to talk about this. So this is where we're going to solve algebraically. So obviously, you know there's going to be more work involved now. We're not just using our calculators. So first thing you got to do, we have to understand that flip idea. Okay, when you solve absolute values, the simple thing I can tell you is you have to solve for the positive piece and the negative piece. Because typically we could have both, right? Now, when you solve for a negative piece, maybe there's not an answer, and that's okay. But we'll get to there. So find the values of the variable which will make the expression within the absolute value symbol equal to 0. So we're finding those zeros, our sections, right? That's what made our W, right? Those two sections were caused by the two zeros that made 3 sections. Okay. All right, and then we have divide the domain into smaller subdomains. Okay, we'll talk about that. I don't like the wording of subdomain. It gets confusing for you guys, so we'll talk about that. Write the absolute value expression in piecewise form, and then solve the resulting equation in the subdomain. So let's just go through here. We're going to solve this problem together. We already know the answer to that one, but we're going to solve it algebraically. Okay. Okay. So the reason I don't really like the subdomain thing is because to me it's simply as this. So 2x plus 3 equals 8, yeah? So we're going to look at the 0 of this is negative 3/2. So what that is, that's just your v happens here. And so we're going to look at the left side and the right side of that 0. That's what they're talking about subdomains, the left and right of those zeros. Okay, let's just make sure we're okay with that. I know that the verbiage makes it confusing. Subdomain sounds weird. Okay, and what we're going to do is that we need to know the left side of this 0, what's the equation of this line? Is it 2x plus 3? No, it's the opposite. So we have to solve for the opposite of 2x plus 3. No, it would be, see how it's negative? It would be minus 2x minus 3 equals 8, and now we just algebraically solve. Be it positive 11. Right, we still have to divide. We divide by negative 2. So remember, that's what we got. We got negative 11 halves. Remember, we got negative 5.5? We've already got this answer before. Okay, so x is negative 5.5, which we got in the calculator already. So we're just kind of algebraically doing the one we did in the calculator. Now you do the one on the right. See how it's 2x plus 3? Why is it saying 2x plus 3? Because the line on the right is the positive piece. So we just keep it 2x plus 3, and we just solve. Minus 3, divide 2, and then again you see we get the, whoops, shadow's in the way, we get the 2.5 again. The same answers we just got. So the big idea is we have to solve for the positive and the negative piece with absolute value, because we know they're in pieces. Okay, let's do one together where we get the subdomains. Huh? Yeah, but what do you want? Okay. Yeah. Sure. Thanks. Okay, so this one, the subdomain, we got to come up with the subdomain. So what's the subdomain of this guy? Not quite. Where's the absolute value? We get our subdomain from the absolute value. What makes the absolute value 0? So negative 3. That's my subdomain. That's my turning point, right? So I want less than negative 3, and I want greater than negative 3. Okay? So what that's doing for you, you have to ask yourself, when you are less than negative 3 with that graph, is the graph positive or negative? It's negative. So we want to go negative 3 minus x equals 2x plus 1. Does that make sense? We want the negative piece. And on the right of it, we want the positive piece. So we just want the regular. And then we just solve those separately. Okay. So let's see here. Let's go add 3 minus 2x minus 2x. I don't know why I'm in red. I don't like red. Okay, that's gone. That's gone. Negative 3x equals 4. So x equals negative 4/3. That's our first solution. Okay. And so now I'm going to explain the subdomain part. So last time we didn't really go over the checking it part, and we're going to explain it here.
If you get the
Sure.
negative 3 with the x. Yeah.
Negative, these two?
No, the one just below that. Just below that. Yeah.
Wouldn't you just add an x and minus 1 and then you'd have negative 3x equals...
Right. You can go either way.
Okay. I was just thinking positive.
Right. You can go, yes, I usually do that. The book kept it all on one side. So guys, you can go whatever side you want. As long as you get negative 4/3, you're fine. But Joel, more specifically, what are you saying?
You just go to that word.
They're here? Okay. So if you want, Joel, let's see here. So I'm just solving for x. So your first step's getting your x's together. So you can move either x, it doesn't matter. I just went ahead and minus the 2x, but you could add the x they're saying. So maybe that's what you would like to do. And so then you'd be negative 3 equals 3x plus 1, minus 1, minus 1. Now divide 3, and you can see either way we're going to get that negative 4/3, okay? So we're going to talk about the subdomain piece and why we're writing these, because these is important why we're writing it, so don't act like we're going to ignore it all the way. We're almost done. Over here, minus the x, 3 equals x plus 1. So simply x is 2. Okay. So what has to happen, what it says up there in the steps, what has to happen when you solve, the answer you get has to be in the subdomain. Okay? So what that means is, see how this is negative 3? And it says less than negative 3? Your answer has to be less than negative 3. It's not. So this one right here is rejected. Right. Okay. The reason being, we did this picture already, remember? This picture, you could see there's only one solution. Because what happens is when you solve this one right here, it thinks it's going to cross again down here. But it doesn't. Okay? So you can confirm that by looking at the picture. Be like, oh, there's only one solution. Okay? But 2, is 2 bigger than negative 3? Yeah, so 2 is good. Okay? Negative 4/3 is not less than negative 3. 2 is bigger than negative 3. So we're good. All right. Okay, we will just finish this one, and maybe I'll just kind of briefly go over the part 2 tomorrow. But let's just finish the page here so you guys get some practice on these ones. Okay, so consider the equation 3 plus x equals 2x plus 1 again. This is one we just did. Okay, write the piecewise. So what does a piecewise be for those solutions? Okay, so we know for 3 plus x, its piecewise, okay, it's 3 plus x for when x is greater than or equal to negative 3. It's negative 3 minus x for when x is less than negative 3. Okay, that's the positive piece and negative piece thing. Okay, and then when we solved, I'm not going to solve for these again because we already did it. But we know when we solved for those two, we got 2 and we got negative 4/3. The negative 4/3 was not less than negative 3. So that one was rejected. Just like reviewing that. And then we're going to get into solving a W one, which I know you'll enjoy. Okay. Yeah, so the negative 4/3 was from solving this one, and it's not less than negative 3, so it doesn't happen. So it's like, think about it as a number line, Jared, and this is a good question. Here's your negative 3. Negative 4/3 is right here. It has to be over here. It has to be less than, so it doesn't happen. Because it's not past the negative 3. All right, let's look at a W and we'll call it a day, okay? We'll call it a day. You guys get on the board and do some stuff. Okay, so we got consider the equation x squared minus 9 equals 7. Solve it by graphing. We'll do that second. Let's do the algebra first. I think you guys can do the graphing. Solved by algebra. So we need to know a couple things, right? What is the subdomain? Now this is interesting. Plus or minus 3, right? It's going to be plus or minus 3 because we have 3 and negative 3 gets you 0. So we just know what that means. Whoops. You get used to these, but you can graph these real quick. Watch. 1, 2, 3, 1, 2, 3. It's supposed to go negative 9, but I know it won't go to negative 9. It'll go to positive 9, right? And so your graph's going to look like this. I'll do the green is the positive piece. The red's the negative piece, the piece that we have to flip. That's what it's going to look like. And then 7 would be here. So you know, just by that, we're going to get what? 1, 2, 3, 4 answers. We're expecting 4 answers. Okay? Okay. So we have this is how you do this. So we have 3 or negative 3 and 3. That's how I kind of draw it. You don't have to draw as specific as they do. I like to do like this. So I know that I have 1, 2, 3 sections I'm solving. Did I see that? And why do I have 3 sections? Because you look, I have 1, 2, 3 sections of the graph, right? So what you need to do is when I am before negative 3, so when I'm over here, is that a positive piece or negative piece of the graph? It's positive. It's the green piece, see? It's the green piece. That's a normal parabola. So that's called the I know you're thinking it's going down for slope, but this is not a slope. It's a parabola. Got it? Okay, so that's a positive piece. So that means that I do just this. I do just x squared minus 9 equals 7. Whoops, I wrote 6. That's weird. Okay, x squared minus 9 equals 7 for that piece. Okay, in the middle is the negative piece. So that means I do negative x squared plus 9 equals 7. And then the outside is the same work as the left side. So we don't have to do it again, but we'll write, that's what we're going to solve. It's the positive piece. And then we solve. So this one I like because if I add 9, well, we do need to solve both of them, and I'll show you why, but you'll see. X squared 16. When you square root 16, what do you get? 4, but we have to, since we're solving, it's got to be plus or minus 4. But is positive 4 less than negative 3? No, so then we only want the negative for that section. But you want to know it's plus or minus. Okay, the reason we'll stay with that, we know this is going to be the same thing, right? Equals plus or minus 4, but is negative 4 bigger than 3? No, only the positives here, so that you get them both. So negative 4 and positive 4 are solutions. So that's going to be these guys. Okay. Everybody with me? I know this is complicated. Last section here. Minus 9, negative x squared equals negative 2. Okay, this is actually right off your test in terms of exact answers. X squared equals 2, square root of 2. So x is plus or minus root 2. Now, you ask yourself, is plus or minus root 2 less than 3
Yes.
and bigger than negative 3? It is. So those are both solutions, and that's what these are. Okay, so your answers are negative 4, negative root 2, root 2, and 4. That's your 4 solutions. Okay, I'll pause the video. You can ask questions.